Hey guys, so this is the second part to the video for combining complex fractions. So this one's just going to focus more on solving for x when you have complex fractions. So let's begin. So I have the first example for solving for x written out here. So we're going to start by looking at the different things and seeing if we can factor them or seeing if we can cross certain things out. So what you always want to do for solving for x is seeing if you can eliminate the denominators. So as we can see, there's an x minus 3 here, and it looks like there could be here and here too. So we're just going to look to see if we can get them all to be x minus 3 so that we can eliminate the denominators total. So looking at this first polynomial here, we can see that it's not going to be factorable because the minus 6 at the end is not going to make any way for the 8 to happen. So we're just going to leave that as it is, and then we're going to move on to this one right here. So we can see that this, though it isn't factorable, a 2x can be taken out of it. So we can have 2x times x plus 3 over, and then we'll factor the bottom, x minus 3 times x plus 3. And we can see that these can cancel out. And then moving on to the second part, we can see that this is most likely not going to be factorable. However, it does look like a cubic, or a part of a cubic. And since there's a cubic on the bottom here, we're probably going to get that to cancel out. So we have x squared plus 3x plus 9. The bottom, we're just factoring a cubic, so x minus 3 times x squared plus 3x plus 9. Obviously, these can cancel out. And we're just going to put on the other side equals our original, so x squared plus 8x minus 6 over x minus 3. Now at this point, I'm just going to I'm going to cross these out completely. Those are crossed out. Those are crossed out. So all that we have left is this, these, and 1 over that. So we can see that all the denominators have an x minus 3 on the bottom. So we're just going to cross all those out. And we can see that our new equation is going to look like this. So when we go to solve for this, we can move everything over to one side. X squared plus 6x minus 7 equals 0. When we factor this, we get x plus 7 times x minus 1 equals 0. So then we get x equals 1, x equals negative 7. So those are going to be our two solutions to this, and if you go through and check, which I do recommend doing on the test, you can see that those are correct. Moving on to our second example, this one's a little bit harder, I think. It's just more complex when it comes to crossing things out. So for this one, because the denominators are all so different, we're probably not going to be able to get the whole denominators to cancel out, which is annoying, but that's okay. So we're just going to work on crossing things out. So for the first, we can see that this is going to be factorable, so we can have x plus 5 times x plus 6 over x plus 5 times x minus 1. So we can obviously see that these are going to cancel out. And then we have equals x plus 4 times x minus 3 over x plus 4 times x minus 1. So these are going to cancel out. And then we have plus x plus 6 times x plus 2 over x minus 6 times x plus 2. So these can cancel out also. So then when we rewrite our equation, we can see that it's 2 times x plus 6 over x minus 1 equals x minus 3 over x minus 1 plus x plus 6 over x minus 6. And now we're going to work on combining this side right here so that we can cross multiply with the other side. So just working with this side, we can see that if we want to combine them, we're going to have to make the denominators the same. So we can do x minus 3 times x minus 6 plus x plus 6 times x minus 1, and then that's all over the same denominator now. X minus 1 times x minus 6, and that is all equal to 2 times x plus 6 over x minus 1. Okay, so now we're at this point, and if we want to eventually combine them, we're going to need to make these into one statement. So we have 2 times x plus 6 over x minus 1 equals x squared minus 9x plus 18 plus x squared plus 5x minus 6 over x squared minus 7x plus 6. Now when we combine these, we can see that it's 2 times x plus 6 over x minus 1 equals 2x squared minus 4x plus 12 over, and then we're actually just going to keep this factored for now, x minus 1 times x minus 6. And now moving on, you can see this is just written up top here. Then now we can actually cross multiply. So we have 2 times x plus 6, and we're cross multiplying here. So we have times x minus 1 times x minus 6 equals x minus 1 times 2 times x squared minus 2x plus 6, which obviously is not factorable. So now looking at the things that we can cross out here, and I'll cross them out in green, we can see that the 2's are going to cross out, and we can see that the x minus 1's are going to cross out. So now when we simplify this equation, we get x squared minus 36 equals x squared minus 2x plus 6. And then obviously the x squareds here are going to cancel out. And then we're left with negative 36 equals negative 2x plus 6. So when we solve for this, we have negative 42 equals negative 2x. And then we have x equals 21. And when you check this, this does work out. So we know that's the right answer. So that's the second part, and that's for how to solve for x. So basically the two things that we went over today were, if you can eliminate the denominators, do so, and keep the numerators, which is the first tip on your sheet. We saw that in the first example. And then the second one says use tips from combining fractions to help you, so that we can kind of see in the second example, cross out as many things as possible, try and get it to be able to cross multiply so that you can easily cancel things out. And usually you're going to find at least one term, usually 2 or 3. So hope that helped. Yeah.